Imagine a star, millions of times brighter than our sun, suddenly erupting in the vast expanse of space. This is a supernova, a cosmic explosion of unimaginable power. These celestial fireworks mark the end of a star's life, but they also signal the beginning of something new. Supernovae are more than just dazzling displays of light. They are crucial events that shape the universe as we know it. These explosions release a tremendous amount of energy, briefly outshining entire galaxies. The light from a single supernova can be visible across billions of light years, traveling through the cosmos for eons. Studying these events gives us a glimpse into the life cycle of stars and the origins of the elements that make up our world. A supernova marks the explosive death of a star in the vast universe. But from these fierce deaths come bright new beginnings. The material expelled during a supernova explosion is rich in heavy elements, the building blocks of planets and life itself. These elements are scattered throughout space, seeding the interstellar medium with the essential ingredients for new stars, planets, and even life. Understanding supernovae helps us answer fundamental questions about our own existence in the cosmos. Where did the carbon in our bodies come from? The iron in our blood? The calcium in our bones? The answer lies in these stellar explosions, which scattered the elements forged in the hearts of stars throughout the cosmos. We are, in a very real sense, children of the stars. Stars, like our sun, are born within giant clouds of gas and dust. These clouds, known as nebulae, are the stellar nurseries of the universe, where the magic of star creation takes place. Gravity pulls these materials together, causing them to collapse and heat up. As the cloud shrinks, its core becomes denser and hotter, setting the stage for the birth of a new star. Eventually, the pressure and temperature in the core become so intense that nuclear fusion ignites, and a star is born. This process of nuclear fusion is what allows the star to shine, releasing enormous amounts of energy. The life of a star is a delicate balancing act between the inward pull of gravity and the outward push of nuclear fusion. This balance is what keeps the star stable for most of its life. Massive stars, many times heavier than our sun, live fast and die young. Because of their large mass, these stars have a much shorter lifespan compared to smaller, less massive stars. They burn through their nuclear fuel much more quickly, fusing hydrogen into helium. This fusion process is extremely efficient, but it also means that the fuel runs out faster, and then into heavier elements like carbon, oxygen, and silicon. As the star ages, it continues to fuse heavier and heavier elements in its core. This process continues until the star's core is made mostly of iron, at which point fusion can no longer release energy. Iron is the end point of nuclear fusion in stars. As fusing iron does not produce energy, it consumes it. When this happens, the star can no longer support itself against gravity and collapses, often resulting in a spectacular supernova explosion. This explosion disperses the heavy elements into space, seeding new nebulae and continuing the cycle of stellar life. Section 4. 2 paths to a spectacular end. There are 2 main types of supernovae, each with a unique origin story. Type 2. Supernovae occur when a massive star runs out of nuclear fuel and its core collapses under its own gravity. This collapse happens so fast that it creates a shockwave that rips the star apart, resulting in a colossal explosion. Type Ia supernovae, on the other hand, involve a different kind of stellar drama. These explosions occur in binary star systems, where a white dwarf star, the dense remnant of a sun-like star, pulls material from its companion star. This process continues until the white dwarf reaches a critical mass and undergoes a runaway nuclear reaction, leading to a brilliant explosion. Section 5. Cosmic Alchemy, Forging the Elements of Life. In this section, we will explore how the elements essential for life are created in the vast and mysterious universe. Supernovae are the ultimate cosmic alchemists, responsible for creating the elements that make up everything around us. These stellar explosions are cataclysmic events that mark the end of a massive star's life. During their lifetimes, stars fuse lighter elements into heavier ones, like hydrogen into helium, and helium into carbon. This process of nuclear fusion is what keeps stars shining for millions of years. But it is the intense heat and pressure of a supernova explosion that allows for the creation of elements heavier than iron. The energy released in a supernova is so immense that it can forge elements like gold and uranium in fractions of a second. These elements, including gold, silver, and uranium, are then dispersed into the interstellar medium, enriching future generations of stars and planets. Without these explosions, many of the elements we consider precious wouldn't exist, and uranium are dispersed into the interstellar medium, enriching future generations of stars and planets. These elements mix with clouds of gas and dust, forming new stars and planetary systems. The iron in our blood, which is essential for carrying oxygen throughout our bodies, originated in the core of stars that exploded eons ago. The calcium in our bones, which gives us structure and strength, was also forged in the heart of dying stars. Without these elements, life as we know it wouldn't be possible. And the oxygen we breathe were forged in the heart of dying stars. Every breath we take is connected to these cosmic processes. The atoms that make up our bodies were once part of a star that exploded billions of years ago, scattering its enriched contents across the cosmos. This stellar material was recycled into new forms, eventually forming planets, and ultimately, life, scattering its enriched contents across the cosmos. This cycle of star birth, life, and death is fundamental to the evolution of the universe. This connection to the cosmos highlights the profound impact of supernova on the universe and our place within it. It reminds us that we are, in essence, stardust, and that our very existence is intricately linked to these cosmic events. Section 6. Unraveling the secrets of supernovae. Supernovae are one of the most spectacular and powerful events in the universe. These stellar explosions mark the end of a massive star's life and can outshine entire galaxies for a brief period. Despite their importance, supernovae are still shrouded in mystery. Not only are these explosions visually stunning, but they also play a crucial role in creating heavy elements that are essential for life as we know it. Astronomers are constantly striving to understand the complex physics behind these explosions, using advanced telescopes and computer simulations to unravel their secrets. Each new observation and simulation brings us one step closer to understanding these cosmic phenomena. One of the biggest mysteries surrounding supernovae is the mechanism that triggers the core collapse in Type II supernovae. This type of supernova occurs when a massive star runs out of nuclear fuel and its core collapses under its own gravity. While we understand the basic principles, the details of this process remain elusive. Scientists are trying to figure out exactly how the core collapse leads to the star's explosion and what factors influence the intensity and shape of the blast. Another area of active research is the role of neutrinos in supernova explosions. Neutrinos are subatomic particles that are produced in vast quantities during the core collapse of a star. Neutrinos are subatomic particles that interact very weakly with matter, making them difficult to detect. However, studying them is crucial for understanding the inner workings of supernova. However, they are believed to play a crucial role in the collapse of massive star cores and the ejection of material during a supernova. Neutrinos can carry away a significant amount of energy from the collapsing core, facilitating the explosion. By studying supernova neutrinos, astronomers hope to gain a better understanding of these events and the nature of gravity itself. Each discovery in this area not only helps us understand supernova, but also provides valuable insights into the fundamental physics of the universe. Section 7. The Universe, a tapestry of wonder. Supernovae in all their destructive beauty remind us of the vastness and wonder of the universe. These events, though they mark the end for some stars, are essential for the birth of new stars, planets, and even life itself. The atoms that make up our bodies were once part of these distant explosions, connecting us to the cosmos in a profound way. As we continue to explore the universe, we are constantly reminded of its immense scale and the countless mysteries it holds. Supernova, with their fleeting brilliance and lasting impact, serve as a testament to the beauty, power, and interconnectedness of the cosmos. They urge us to look up in awe and to continue exploring the universe, seeking answers to the profound questions these cosmic events pose.